Okay, so Newton's law of motion and friction. What are the key concepts? We already talked about force. Okay, what is the force? So there are type of forces available. One is gravitational force. Okay, another one is contact force. That is very important. So contact force is a two type of forces in contact force. That is a normal force. So normal force when it is occurring.
Normal force. Normal force occurs when one force is like an object is on ground. There are two blocks. The
Okay,
normal force is action.
the best example, if I am standing, so earth is applying a normal force on me,
Yeah.
so that is upward. Okay, I am applying I am having weight, so weight is downward and normal force is upward to the weight. Okay,
Yeah.
so these two forces are balancing each other, that's why I am standing. Got
Yeah.
it? So once there is a surface in contact, so that surface will apply a normal force, and that normal force is always perpendicular to the surface. That's why it is called as normal force. Okay. Okay. Now another one is frictional force. Frictional force you already know, the surface. If somebody is in contact with the surface, and let us say it is in motion, so that surface will apply a resistive force on the body, or it will just uh, try to just obstacle in its motion. Okay, so that is called as friction force, isn't it? Okay, so these two type of forces are said to be contact force because they are existing only once the body is in contact with the surface.
Can they be greater than the applied force?
Which one? Friction?
Uh, yeah, friction or normal. Can they be greater?
Yeah, it can be greater than the applied force. If I am standing here, or you can say if some heavy ball is there and you are just applying a force and it is not rolling, so what is happening?
Okay, it's greater.
Yeah, so whatever force you are applying, it is not greater than the forces which are already applied. Okay, so that's
Okay.
why it is not moving. If you are applying a force on wall, so that is not moving anywhere. That means your applied force is lesser, isn't it?
Yes.
Yeah. Another one is tension force. Tension force comes into the picture once there is a string string type of material is there. Okay,
Yeah.
if the ball is hanging by some string, so that will be having a tension. Okay,
Yes.
you have high tension wires, so they are also in a tension. Okay, so tension means once the string is attached by something and it is stretched, so it will be having a tension. Okay, and
Yeah.
just consider the directions also, in which direction normal is perpendicular to the perpendicular to the surface always, and friction force is always opposite to the direction of body.
Yeah.
Okay, it is always opposite. Okay, now we'll talk about tension. So this string is attached here with the block. Okay, you are just pulling it. So if you're just pulling it, so tension will be on the string. Okay, so there are two
Yeah.
kind of tension. So due to string on the block and due to string on the hand, so string will be facing two type of tension. Block will produce one tension and your hand is producing another tension.
Yes.
Okay, and they are in the balance, that's why your block is nowhere moving.
Okay.
Okay, so if you are applying more force, so the block tension will be less, so that block will be moving.
So tension is kind of like contact force.
No, it's not a kind of contact force.
Like, but it's acting in opposite direction only happens
See,
when you're in
see,
contact.
if you are having a ball attached with a string,
Yeah.
so is that ball is in contact with any surface?
No.
That's why it is not a contact force.
But your hand is in contact with the string, right?
Yeah, your hand is in a contact with the string, but not with the contact ball.
Okay.
Okay. So if body is in contact with the surface, so that force is said to be the contact force.
Okay.
Okay. There are two type of contact forces only. That is normal force and is frictional force. Okay.
Okay.
Now string passing over a pulley, if the string passing over a pulley, that will have also tension. Okay.
Yes.
So the direction of tension will be like this. Got it?
Yeah.
So these are some kind of forces. Spring force you already know. What is spring force? If you are just pushing the compressed string will be having a force on the wall.
Yeah.
Okay. And if you are stretching the string, it will also be having a force. Okay.
Yeah.
Got it?
Yes.
So if you are pressing the string, spring, so that will be compression. If you
Yeah.
are stretching it, it will be an elongation. It is called as elongation.
Elongation.
And that is given by Hooke's law. That force is given by
Hooks law.
Hooke's law. What is Hooke's law? Do you know that?
Yes.
What is that? F is equal to minus kx.
Minus kx.
Yes,
So it was kx, right?
it is minus.
Okay.
Okay. Because this force is always applied to the direction of spring in which it is going. It is always opposite to the direction. If you are pushing, if you are compressing the spring, so you have been feeling a force on your palm. Okay.
Yeah.
So that force is opposite to the direction of compression, isn't it?
Yeah.
So that's why your minus sign is used.
So it's basically like tension.
uh, we can't say tension because no string is attached. Okay.
But spring is also kind of like string, right?
But it is kept in different category.
Okay.
Okay, because its formula is different, that's why it is kept in different category. So it is a spring force, we can say it. Okay.
Okay.
K is
Yeah.
a constant value because K is spring constant, so that having constant value. Now Newton's laws of motion, the first law, do you know the inertia? What is the inertia?
Inertia.
Yeah.
The I'm not exactly sure. Only remember bits of it.
Inertia is the property of a body that oppose the change in its position. Okay.
Okay.
So it is a characteristic of a body that doesn't want to change its own characteristic.
Resistance to change,
Yeah, so
basically.
that is, you can say it is a resistance to change. So if you are applying a force on the body, it will resist. It is not very
Okay.
simple to move something to that place to that place, is it?
Yeah. Yes.
So what resistance is there? So that resistance is a property of that body, and that resistance is called as inertia. Okay.
Okay.
If some
Yes.
body is in rest, so the tendency of a material body to preserve its present state of uniform motion. or of rest is known as the inertia of the body. So that property is said to be the inertia of the body. Okay?
So even if an object is moving with constant speed,
Yeah.
inertia will still be there.
Yeah. So if it is in a constant speed, you need to apply a force to stop it. Okay.
Yes.
So that also at that time the body is applying a resistance for the change. Okay.
Yes.
So inertia is a physical quantity and mass of a metal body is measure of its inertia. So it is measured in terms of mass. Okay, got it?
Yes.
So mass is a measurement, sometimes we can say mass is a measurement of inertia.
So how is mass measurement of inertia?
You
Kiran?
will know that if you read more. Bus, uh, but you can say that inertia, if you're measuring inertia, so that will be given in terms of mass.
Because of F is equal to ma.
No. I equal to I inertia is mr square. You will see that for a different body, different inertia is there.
Okay.
मुझे कोई नई नई सीरीज स्टार्ट करनी है
You got it?
Yes.
Okay. So for different bodies, we have different inertias. Okay.
Yeah.
So inertial frame of reference I told you yesterday.
Yeah.
So the first law requires a frame of reference in which only the forces acting on a body can be responsible for any acceleration produced in the body, and note the acceleration of the frame of the reference. These frames of reference are known as inertial frames. The second law we already discussed in the previous class. Okay.
Yes.
Okay. Now the third. Okay.
Sir, can you explain the difference between inertial and non-inertial frame?
Yeah. See, in which your Newton's law of motion holds, that is said to be the inertial frame.
Yes.
Okay.
Yes.
So now we'll see some questions based upon this one. First question. Just tell me the answer for this question.
1 second.
Because we need to practice whatever we did in theory. That is very important.
And pushes upwards with a force of 25 Newton.
See, girls push girl is pushing that book with a 25 Newton. Okay.
Yeah.
So that is 25 Newton. That is FBH, isn't it?
Yeah.
Because this book is between book and hand, the force is 25 Newton. So that is 25 Newton. Okay.
Yeah.
And book weighs 20 Newton. So weight of the book is 20 Newton. Weight
Yeah.
of the book is 20 Newton. So that is downward.
Yes.
Okay. And so what will be the reaction force? What will be the normal force? What will be the contact forces FCB between the ceiling and the book?
5 Newton.
5 Newton. So that is very simple, because girl is pushing that book with 25 Newton and weight is 20 Newton. So they are opposite to each other. So
Yeah.
the force between the ceiling and the book will be only 5
5
Newton. Even she is applying 25 Newton, but it is just like she is applying only 5 Newton, isn't it?
Yes.
So that FCB will be 5 Newton, but once we are talking about the force between book and hand, so that will be 25 Newton.
Not fully understand why don't we, it shouldn't both of them be 5 Newton?
Because the force applied on the book is 25 Newton.
But the book is also applying a force, right?
Book is also applying the force, but he is not bothered about the force what book is applying. He is only bothered about the force what girl is applying on the book.
Yes.
Okay. Clearly he is asking you FBH between the book and her hand. Just only one force. That is 25 Newton. Okay.
Yes.
Okay. Just try third one. Got it. These are some questions based upon two rules of Newton. Okay. For this to understand, I am having this string.
Yeah.
It's a rubber band. It's a TheraBand. Okay. You are just observing it from outside,
Yeah.
isn't it? So the both hands, one hand is just pulling it. Okay, but in space things are different. Okay,
Okay.
they are not fixed in space.
Okay.
So if you pull by this, so that will be tension applied from both of the hands. Okay. So if you are an observer, you will see that both are moving. But who is applying the more force? So
A.
that will be going with the great acceleration.
I
Okay.
didn't fully understand. But why would A move? But like A should remain stationary, right? Because B is not applying any force.
He will not be stationary because he is not fixed. In space, everybody is moving
Why?
because there is no environment. If you
Okay, so,
jump on the space, so in space, everybody is just like floating.
so you will infinitely move upward.
Yes, yes. Okay.
Okay. What if they were on ground? What if two people were on ground and pulling the string?
So the string will be going to that person, or he will uh,
Ideal condition.
ideal condition. If you are applying more force, then
Yeah.
the person will move towards you.
Yeah. Will
Okay.
you move towards him?
No, why you will move? But in space conditions are different. Okay.
Okay. Yeah.
So space conditions are different. So that's why it is a different scenario. So should I send you? So under which condition will an object be in equilibrium? We say the object is in equilibrium once there is net force 0.
So it only A.
Why it is not with a constant? If the body is moving with a constant velocity, isn't?
Because yesterday you said that if an object is moving, then one force would be greater, only then it can move.
But it is moving with the constant velocity.
So, but even if it's moving, then one force is greater, right?
If it is moving with the constant velocity, its acceleration is going to be 0.
Yeah.
So if its acceleration is going to be 0, so how much force?
0.
It is 0. So we say the body is in equilibrium once the net force is 0.
Okay. But how can it be in equilibrium? It's moving forward even with constant velocity. Then it is going forward, then the resistor for then the resistance is less than the forward applied
Yeah,
force.
see, physically it is not looking like it is in equilibrium, but we'll see the questions and then you will understand. But the main definition is if net force is equal to 0 on the body, then it is in equilibrium. So that D part is satisfying the equilibrium condition. Okay?
Okay.
Okay, so just try to do questions from the previous PDF.